Okay, we are going to skip over to section 1.8. I'm going to ask you guys to just read 1.6, 1.7 about the discovery of an electron. And we're going to start looking at our atoms and their subatomic particles. So when I have an atom, it's composed of three different things: protons, neutrons, and electrons. So let's say here is my atom, not a very good atom, and then in my atom, I have a nucleus. The nucleus is in the middle here. Okay, in the nucleus, that's where I'm going to find my protons and my neutrons. Outside the nucleus, that's where I'm going to find my electrons. A couple things. Protons, which we'll just symbolize with a P, they are positively charged. Neutrons, which is symbolized with an N, they have no charge. They're neutral. And then electrons, which will symbolize with an E, they have a negative charge. And we look at it as -1, and for protons, +1. Okay. Now, one thing about atoms overall are neutral. That means in a given atom, you're going to have the same number of protons as you do electrons. They should balance out, so you get a neutral atom. Protons and neutrons, they're pretty similar in their mass. They're almost identical. You can see how little they are. And then the mass of an electron is even smaller. And again, you can see how little it is. Here's a chart from your book that you can use. So again, protons are positively charged. Neutrons are neutral. They don't have a charge. Electrons are negatively charged. You do not need to remember the mass of them. Okay, so our elements are defined by what we call an atomic number. So this comes from your periodic table, and you guys should all print out a periodic table. I will send it to you. But what this is the atomic number defines how many protons are in an element. And that number is never, ever, ever going to change. The atomic number has a symbol, and the symbol is Z. Okay, so I'll give you an example. The atomic number for sodium, atomic number is 11. So Z for sodium would be 11. And what that means is that I have 11 protons in a sodium atom. Here, I'll show you this with a periodic table. If you look, just look here. Our periodic table is arranged, and you just go from left to right. So 1, 2, 3 through 10, 11 through 18, etc. This number here, the one on top, that is your atomic number. So that's the one that tells you how many protons are in whatever atom you're looking at. You can see here for sodium, it has an atomic number of 11. So sodium has 11 protons. Okay. You can see here for oxygen, oxygen has an atomic number of 8. So oxygen has 8 protons. Okay. Now this is super important. Protons, the atomic number will never, ever, 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 ever change. It defines what element you're talking about. So if you have an atomic number of 15, then it is always going to be phosphorus with no question. So atomic number never changes. It defines what element that we have. Okay. Let's go to this. So We also have what's called a mass number. And I'm actually going to go back to the here. All right, let's look at, actually, I don't even have it on there. So let's go back here. Our atoms, although they will always have, like a neon atom will always have the same atomic number. If you look at a periodic table, the atomic number for neon is 10. That doesn't mean they're always going to have the same mass number. Okay, so before I get into that, if you look at a periodic table, and I'm going to pretend I have neon here. I'm going to draw this. So neon has an atomic number of 10. And then on the bottom, the periodic table is going to tell you that neon, there's a number associated down here. So go ahead and write this down. It's 20.18. Okay, so the periodic table gives us, this is our atomic number, which we symbolize with Z. There's another number that comes below the element, and that is our mass number. Okay. Now you'll notice here that the mass number is not a whole number. They're not going to be. The reason being is because not every atom, but most atoms have more than one, what we call isotope. An isotope is when you have an element or an atom like neon. Neon's always going to have an atomic number of 10, but it can have a different mass number. And for example, there are 3 isotopes for neon. There's neon with a mass number of 20, neon with a mass number of 21, and neon with a mass number of 22. But every one of these neons has the same atomic number because it's neon. When I have atoms with the same atomic number but a different mass number, we call those isotopes. Okay, so what does this tell us? To begin with, this setup right here, this setup is what we call the atomic symbol. Atomic symbol. Okay. The atomic symbol is just another way of writing the information of our atomic number and our mass number, differently from what you see on your periodic table. An atomic symbol is written, so you're going to have your symbol of your atom. So in this case, it's neon. And then you're to the side, on the top, you have the mass number. And then you have the atomic number on bottom. And to be perfectly honest, you don't really need the atomic number because neon's always going to have an atomic number of 10. Now the atomic symbol leads us to be able to get some information. So if we know the mass number, then we can figure out the neutrons. Now looking at neon has an atomic number of 10. So that means it has 10 protons. How many electrons does it have? It also has 10, right? Because our atoms are neutral. So our atoms are going to have the same number of protons as they do electrons. And then finally, we have neutrons. So how we get our number of neutrons? So neutrons is equal to the mass number minus the atomic number. So we need the mass number in order to know how many neutrons we have. Okay. So for this neon here with a mass number of 20, it would have 10 neutrons. So 20 minus 10. When neon has a mass number of 21, it's going to have 11 neutrons. 21 minus 10. And then for neon, what we would say neon 22, so mass number of 22, that's going to have 12 neutrons. So again, an isotope is when we have the same atom, but a different number of neutrons, which equates to a different number of, a different mass number. Here's just showing that atomic symbol again in the form we just looked at. So A is our mass number. Our mass number is equal to protons plus neutrons. And then we have our atomic number and then the chemical symbol. So as long as we know those things, we can always determine the number of protons, neutrons, and electrons. So that's one way of writing the atomic symbol. Here's another way, keeping with neon. Like I said, we don't really need to write what the number of protons is or the atomic number because it's always going to be the same for neon. All you need is periodic table to look. Neon has 10 protons. It has an atomic number of 10. And that's going to be the case for all three of our isotopes. So it is important, though, that we identify the mass number. So here's just another way of writing a different notation of our three different isotopes. You can write neon 20, neon 21, neon 22. That just shows us the mass number. Now, if we go back to the little not very good thing I wrote for neon. So we have neon, and its mass number on the periodic table is 20.18. And then its atomic number is 10. Okay. The mass number you get on the periodic table, so this 20.18, this is a weighted average of all the isotopes of neon. So we've just learned that neon has 3 isotopes. That 20.18 is a weighted average of those 3 isotopes. So that's why this is not a whole number. Now, we can make an assumption. We know that we have 3 different isotopes for neon. We have neon 20, 21, and 22. If it's a weighted average, then that means one of these isotopes, or maybe 2, in this case, let's look at 1. One of these isotopes is going to be the majority of that weighted average. So if I look here, 20.18, that's really close to 20, right? Closer to 20 than it is to 21, and definitely more than it is to 22. So I can probably assume that the isotope in the largest quantity is going to be neon 20. And I can see that here. So we can see that and even calculate our weighted results or weighted average if we know the natural abundance of our isotope. And the natural abundance just means what percentage of neon is going to be found to be that isotope. So all of these should add up to be 100, right? So 100% of neon is made up of these 3 things. Well, the natural abundance for neon 20 is almost 90.5%. So this is a little over 90% of that average. And these are your other 2. You can see how little neon 21 there actually is. And this is all what we find in nature. Okay. Okay, moving on. We have in addition to atoms, we have ions. Okay, what is an ion? First, let's go back to what an atom is in terms of electrons and protons. Atoms are neutral, and therefore they have the same number of protons as they do electrons. Ions are not neutral. They have a different number of electrons than protons. Now, we can have a positively charged ion or we can have a negatively charged ion. Positively charged ions, they are called cations. So make sure you note that. Negatively charged ions, they are called anions. Positively charged ions, or cations, they come from metals. So that's super important. Negatively charged ions, they come from nonmetals. I'm going to give you an example with a metal, and I'm going to use sodium. Sodium, okay, sodium atom it has 11 protons and 11 electrons. Okay. The sodium ion looks like this. It has a +1 charge. And I'll explain where that comes from in a little bit. But a sodium ion still has 11 protons because it's sodium. That's not going to change. But it has 10 electrons. And remember, protons are positively charged. Electrons are negatively charged. If I add these up, 11 positives and 10 negatives, I get +1. That's where that charge comes from. So a sodium ion, it's a metal. Metals do what we call lose electrons and forms a positively charged ion called a cation. Nonmetals, they do what we call gain electrons, and they form a negatively charged ion that we call an anion. I can give you an example of this. So fluorine as an atom has 9 protons, and as an atom, because it would be neutral, has 9 electrons. Fluorine tends to gain 1 electron. Now remember, nonmetals gain electrons. So it still has 9 protons, but a fluorine ion actually has 10 electrons. And if I were to add that up, I'd have an overall charge of -1, and a fluorine ion looks like this, F to the -1. Okay, and we'll do a lot more with this as we continue. Okay, so let's look real quick here at a couple examples. Let's see, what are the atomic number, mass number, and symbol for the chlorine isotope with 18 neutrons? Okay, so we're going to go ahead and grab a periodic table. Chlorine, all right. We know we're going to look at chlorine's atomic number. It has an atomic number of 17, which means it has 17 protons. Okay. It tells us that it has 18 neutrons. So then how do I get the mass number? The mass number, remember, is protons plus neutrons. So I have 17 plus 18, which is 35. So that's going to be my mass number. So our mass number is going to go here, 35. And then my atomic number, 17, will go here. So that will be the answer to A. Now let's look at B. I have 52 Cr is chromium, 24. Okay, so This is an atom, there's no charges, so how many protons do I have? Well, that's equal to my atomic number. So I have 24 protons. I have the same number of electrons because it's neutral. And then my neutrons, I'm going to take the mass number, 52, and subtract 24. So I'll have 28 neutrons. Okay. All right, so we are going to move into looking at that weighted average and how to calculate it. So for example, that what I'm talking about is how we can come up with the 20.18 for the mass number for neon when we have those three isotopes. So what we need to be able to do this is we need to be able to know how many isotopes there are and what the abundance of each isotope is. So for example, we're going to look at chlorine. Chlorine has three isotopes as well. And I can calculate this here, this mass number, so this is our weighted average, by using this formula. So to find this, what I need to do is know the isotope and the mass, know the percentage of that isotope and the mass of it. Okay. For example, right, so let's go here. Naturally occurring chlorine consists of 75.77% chlorine 35, and that has a mass of this, and 24.23% chlorine 37. So chlorine, has two isotopes. So here I have chlorine 35, okay, and chlorine 37. Chlorine 35 has a mass of 34.97, and you use AM, it has AMUs here. That's a unit called the atomic mass units. We can also look at this as in grams. So either way, right now I'm just going to leave it as grams. We use those interchangeably. And then it has a naturally occurring abundance. So the abundance of chlorine 35 is 75.77%. Okay, so 75.77% is the same as 0.7577, right? That the percentage is just over 100. So if I put that in fraction form, which I want, or in decimal form, excuse me, I don't want to leave it in the percentage. So this is my natural abundance. So it has a natural abundance of 0.7577 or 75.77%. Right? Then I have chlorine 37. That one weighs 36.97, and it has an abundance of 24.23% or 0.2423. And you want to use all the digits that they give you. Okay, so there's only two isotopes, excuse me, and we should see that because this should add up to be 1, or if we looked at it in percentage form, it should add up to be 100, and it does. Okay, so now to find the mass, so I need this to take the sum of the mass times the abundance. So I'm going to take chlorine 35, so you have 34.97 times 0.7577. So you're taking the mass times the abundance, and then whatever, and then I'm going to add it to the next one. That's where the sum comes in. So 36.97 grams times 0.242 3 for the abundance. Okay, and then we're going to do the math. So if you take 34.97 times 0.7577, that will give you 26.497 plus 36.97 times 0.2423, and that will give me 8.958. Okay, so then we'll add those together, and you get 35.455. And if you look on a periodic table, you will see that 35.45 is what you see for the mass number underneath the elemental symbol.